Hello, welcome to Lazy Tech. Did you ever wonder how to scale up your database? Today I will show you different ways to do that. So let's get started. We have several ways to scale our database. So we have the leader follower replications, the multi-leader replication, the leaderless replication where we don't use the leaders, the federation, the sharding, denormalisation, and SQL tuning just from your SQL stuff. Let's go to the first one, the leader and followers replications. The advantage here we see that we can handle more risk because we have more slaves replicate from the master. So if the master go offline, it can still continue to operate the read only, and it has the way to promote the slave to a master. So it also has some disadvantage here. It's complicated the logic for promoting the slave to a master, and it can potentially lose the data because when the slave is not up to date, get the data up to date from the master, and it gets the replication lags when it's serving more reads and writes here because we more reads for the more writes, and the slave have to replicate a lot, and it's also the slave have to also like responsible for the read, so it can cause the replication lags, and it also adds more hardware and additional complexity for that. And so we also have the asynchronous replication because if we want to synchronize it, it really slows for that. So the asynchronous here replication is also a disadvantage. And the system can only read if the master down, as you can see in the system. The multi-leader replications help us to serve more write requests, also the read request. And it helps us to mitigate the master failure because we have many leaders can serve the write, and it has some advantage of like the master slave. It also has the same disadvantage as master slave, and to serving this one, it needs the load balancer to choose which leader to send the request to, and it loses the consistency because we have to sync multiple leaders together to get the latest update. We have the leaderless replication where we don't use any leader here. The Rika, Cassandra, and Wunderbolt are open source data source with the leaderless replication that inspired by Dynamo. The Dynamo here is not DynamoDB by AWS. Dynamo is just like a paper research, the architecture of that. They can write and read requests sent to several replicas here. So they can see when it writes a new, for the value new image here, it writes to several replicas, and the replica trees fail. So when another user read that, so it read the replica 1 and 2, and the 3 is the old value. So now it's new. It know that it's voting. It know that the old value, it has the new values. So it will update the node replica 3 with the latest value for that. It also had the repair strategy. So the client will write newer values back to stale replicas, as I said in replica 3, and it used the anti-entropy process, the background checks run in that to get the latest update between replicas. We have the federation. The federation here is for functional partition. It split up your database by functions. So it has advantage here. It get less replication lag. It can get more cache hit because the summer database, summer table here is small and it can fit to the cache. So no single central master serializing, right? So you can write in parallel, increasing the throughput. And it also has disadvantage. It's not effective if your schema requires the huge function or tables. It needs to update your application logic to determine which database to read and write. And the joining here is really expensive for different databases. And federation adds more hardware and the additional complexities. So like, for example, we had the forums, the user, and the product database. We have the sharding technique. You distribute data across different databases, such that each database can read only and manage subset of data. You got this advantage here. If you less replication lag, get more cached hit, the same as federation. There's no single central master serializing, right? So you can write in parallel, increasing the throughput. It also got a disadvantage here. The complex SQL query when you want to query something. And the data distribute can become loop-side. So data can be sit many data into some node and others read few. So to rebalance that, it will add additional complexity like use consistent hashing. So consistent hashing will solve that problem. We also need to add more hardware, additional complexity to handle this. The denormalization. So as you know, we had a Justin Bieber problems where Justin Bieber had a post and Instagram cannot handle the light there. So to solve that, the teams is adding more, just another view in the table, like the total of the light. So we don't need to count total of the view anymore anytime it's get the request. So denormalization here, it will improve the read performance at the expense of some write performance. And it got disadvantage here. The data is duplicated and increased complexity of database is design. And the denormalization database here is under heavy write load, might perform worse than normalized counterpart. So forget about the architecture. Just the simple one is just focus on your SQL only. Your schema, have you used a good indexes? Have you avoided expensive choice? Or have you tried to partition your table yet or not? So go to the schema. So use jar instead of varchar for fixed length field. So it will allocate the fixed size for your chart. And the jar is effective, allow for fast and random access. And whereas the varchar, you have to find the most end of the string before move to the next one. And use text for a large block of text, such as blog post. Integer for large number up to 4 billions. Use decimal for currency to avoid floating point representation error. Avoid storing large block. Just store the location where to get the object. Varchar 25.5 is the largest number of characters can be counted in any bit number. So set not doing constant where applicable to improve search performance. Use the good index. Understand the order of the execution in your SQL query. So you can add the good indexes in the select, group by, order, and choice to be faster. And indexes usually represent several B trees and keep data source allow searches, sequential access, insertion and deletion logarithm. And placing an index can keep the data in memory, requires more space. And write could be slower since the index needs to be updated. So don't use a lot of indexes, just use the suitable amount. And when loading large amount of data, it may be faster to disable indexes, load the data, and rebuild the indexes later. The other ways, like avoid expensive choice, as I said, like try to denormalize where performance demand is, and partition the table, break the table by putting hotspot in separate table to keep it in memory. That will faster. And tune your query cache. In some case, the query cache could lead to performance issues. The query, if like your queries change or your database read always change, and the cache is always updated, so it doesn't have much. So these are all the ways to scale up. You can think about this when you want to scale up. And you can choose the different ways that's suitable in your current stage, in your current company problems. And I recommend that you can start from your SQL first, and then think about hardware, like architecture, like replications, like that. Thank you very much. See you later. If you find it interesting, please subscribe and leave your comment if you love it. Thank you very much. Bye.